borrowing kind of from Andrew's talk, there was his second to last slide talked about structured data leading into possibilities for AI. And that's probably the core of what I'm going to talk about today. So it's a little bit more in the American football lingo, the blocking and the tackling that allows you to get to that point. Because digital transformation is what are the things that you're doing at your company that basically allow you to get to that structured, curated data. And then the liberation is not like you're removing people from the equation, but they're freed up from the drudgery and the tedium so that they can actually solve the more complex problems and do some of the more interesting things, as well as being creative. So in a way, digital transformation equals digital liberation. Here we go. Or it's basically, like I said, liberating AI through good data. So taking a step back, like, all right, who is BASF? BASF at a glance is a very large chemical company. We have 6 major divisions in terms of our overall businesses. And there's a lot of global challenges that motivate us to do what we do. So whether it's thinking about food supply for the world, whether it's thinking about different kinds of things that go into pharma ingredients, nutrition ingredients, there's just a ton of problems. And so it is an exciting area to work in. Now, for me specifically, I've been at a company that was acquired by BASF, so the entirety of it is almost 20 years now, and we fall into the nutrition and care division. So nutrition and care looks at nutrition, health, different kinds of care chemicals that impact our daily lives. And here you can see kind of a smattering of what that looks like. So that goes to animal nutrition as well as human nutrition. It goes to different kinds of things that touch us. And specifically, I'm in enzymes. And BASF has been in enzymes for 30 years or so now. And we've had a lot of products and a fair amount of partnering. And basically what we're interested in doing is developing high performance enzymes that really do create opportunities for our customers. So meeting their high value needs. And specifically within enzymes, we have different markets that we address, whether it's bioenergy. You can easily think of home care and laundry, like getting your clothes clean, animal nutrition, human nutrition, and then there's a couple other technical areas. So what's important to us for enzymes? And you can boil this down into 4 things. So the enzymes themselves are important, but you have to carry that all the way through to the customer. So how do we make the enzymes? We put them in different host strains, and we have fermentation that does the bulk of our production for us. So we're very interested in the strains themselves. As well, the strains aren't going to ferment themselves, so we have a lot of talented engineers that are interested in the processes that we use for production. And finally, having a degree of humility, we realize that the customer is maybe not quite as excited about that enzyme structure as I am, being a structural biologist, but they're interested in customer performance. So they're interested in, as a business person, what's going to meet their needs for kind of low cost inputs and high value outputs. So if we then start to get into the data area, like how do we liberate our bench scientists? And you can imagine there's a lot of data in a lot of different disciplines that get to that level of customer performance. And so if you look at it this way, where we have to actually look at, there is no perfect one single off-the-shelf product that is going to make the difference for us in terms of really liberating the bench scientists. So what we need to do is we need to take some of the best blending of off-the-shelf products as well as custom products. So within our ecosystem that I describe here, we have basically tools for enzyme analysis and management. We've got to do a lot of screening, whether it's with strains or enzymes. And so we've developed some tools that are kind of specific to us, but they're built on some common platforms that allow us to essentially evaluate data in high throughput fashion and make sure that it's stored and structured in a good way. As you know, blocking and tackling, sequence management and strain management is par for the course. But we need to integrate that with some of the other tools. And just a few of them that I'll sort of highlight how we do this here in the next couple slides. Definitely taking advantage of things that, we don't want to reinvent the wheel. So, JUMP has a lot of great tools for interactive visualization. At the core of a lot of what we do, we actually have implemented Riffin over the last couple of years, and I'll tell you a little bit more about that. Being in production and being a big production company, we've used obviously OSI Pi and some of the tools there for years. And then underlying all of that are some master databases that we need to keep track of the strains. We need to know what our assets are. So what did we need in terms of being able to really operate here? We needed basically flexibility. That was probably at the very top of the list. We had an aging limb system that was great for the workflow that we developed 20 years ago. But as digital biology continues, you can dream up a sequence and get it synthesized and put it into experiments. We needed flexibility to kind of not tie us to one single workflow. Also, at the same time, we needed to say, hey, this isn't the Wild West. We need a certain amount of data governance, which includes kind of tying ourselves to master data keywords, as well as improving our data quality. Because I'm sure that many of you at companies, you have SharePoint folders from 10 years ago, and what did we do in that project? And you need some people or some experts to kind of go in and remember what you did. But we're trying to structure our data now so that that isn't really so necessary, such that it would be very obvious. So you can really kind of capture the experiment and the context along with the data. In addition to that, if you're going to liberate bench scientists, you do need to streamline your user experience. Like I said, to make it more kind of time efficient for them and interesting. And then automate as much as you can. So clearly, anything that can relieve a copy-paste operation not only should be done, but must be done. So if we talk briefly a little bit, like how do we, I said we use Riffin kind of at the core of things. Well, what does that look like? You start off basically with a certain amount of process design. So you can see these little rectangles that are like, those are your process steps. And you've got inputs and outputs. And so you can track where that goes. And by tracking this in a system like Riffin, you can actually continue to have the context persist. So that's where you get the meaning out of your data. Once you set up that overall scheme, you have to define like some of the specifics, like where the data is coming from, what you're going to do with it. You can then take that and make sure that you link the right experiments when you're actually going to push forward to analysis. So if you look at this, you think about this as kind of an overall kind of CAD for experimentation, and that works really well for us, for bench scientists, trying to essentially figure out what we want to do. Here's an example in enzyme engineering where Riffin is at the core of it, but we needed more in terms of actually like making sure that backbone really had some muscle attached to it and could flex its muscles. So when we do enzyme engineering, we essentially like make a library, we grow it, we harvest it, but we save some for glycerol stocking for future experiments. And the harvested material actually goes to the high throughput screening that I talked about. How are you going to set that up? Well, we do high throughput screening like many people do in microtiter plates. Here's just an example of like, peppering the microtiter plate with positive and negative controls. And then the rest of the white wells are basically samples. And being able to kind of set this up with our own apps that tie back to kind of a backbone like we have in Riffin allows us kind of a lot of flexibility, but it allows us to do this quickly. We can save these templates and kind of use them again and again in the future. Then we collect the data. And, people have different ways of dealing with high throughput data. We've just heard Andrew's description of looking at quality calls for sequencing. We're going to look at some performance data, whether it be strains or enzymes, deal with that statistically, but then provide tools like this that people can essentially provide kind of smart cutoffs, logic to the threshold or heuristic decision making. And then have that persist. So not only like have it stay right there in terms of picking your hits, but as I said before, we really don't want to copy and paste. So if at all possible, we try to have things like this HTS dashboard already feed the hit picks kind of back into a robot hit picking scheme, that instead of now screening like thousands of plates, you're now just screening a few plates, and the robot knows where to grab those samples. So it really does kind of accelerate that process to make it a little bit more at an intuitive pace. Another thing that I talked about is fermentation. So this is, again, the bread and the butter of how we make our products. And we want to capture data and processes, like I talked about, at small scale, as well as at production scale. And what we have pictured here, basically, you've got some familiar, hopefully to all of you, DOS skip fermenters. And like any good engineer, we try to like drill as many holes into the top and capture as much data as we can, limited to the kind of the surface area of that top right there. But we're going to try to capture a bunch such that we can compare that data, and if possible, actually compare it across scales, even all the way to production scale. So we built kind of an interactive dashboard. The data goes in, the data is parsed, and so this is coming from essentially like just regular data capture in the lab. We've tried to implement OSI Pi, where we capture that both in the lab as well as at production. And we can normalize this to make sure that we're comparing across scales accurately. Now, once we have this, we've got these kind of dashboard metrics that allow us to do some easy comparisons. In this particular experiment, obviously, we're looking at the red line for improved performance over kind of a baseline process that there was before. But in order to capture that and capture the context, it captures the metadata along with it. And that's a big time saver for us for like grouping runs into different experimental conditions. And like I said before, we're able to better handle data and experiments that these things are roughly like 200, our production is around like 190,000 liters, whereas a DOS skip you may have half a liter. So being able to compare that across scales and being predictive at a smaller scale is really key to us. So the other thing that this allows us to do after we've kind of stripped it all this together is concatenate additional runs. So if we did an analysis, we saw how a run in the lab went, but we wanted to feed in a previous run that had been done at the production scale, we can do that pretty quick. And in truth, like this whole process of taking this data, feeding it in, and getting the dashboard takes roughly about 10 minutes. And most of that time is actually going through, OSI Pi is a wonderful data historian and will capture by the second. We don't need really by the second for this kind of dashboard. So most of the time is actually spent kind of culling some of that data. But really in the less than the time that I'm talking to you today is where this analysis can be done. And I mean, the joke really around here is like, now that it's kind of down to 10 minutes, the scientists and engineers are kind of getting a little impatient during those 10 minutes. So they want to kind of Google over or look at different experiments while they're waiting during that 10 minutes. So that's kind of at the heart of what we are able to get out of that. And this is where, kind of going back to this overall theme, where you're really enabling AI through good data and flexible and streamlined processes. So for us, it's very specific. So in terms of that analysis that I talked about that takes 10 minutes, it's roughly 25 times faster than what we had done previously, and enables sharing immediately. So BASF is a global company. Enzymes is based in more than one site. And so we're able to actually share that data more readily now. Another thing that we have in terms of the ability to look at different enzymes, whether it's at a discovery or an evolution phase, it really allows us roughly kind of a 5 times increase in productivity of evaluating that. Now, what that moves us into then is something that, it's very kind of nascent, it's early stage, so I can't really talk about it here today, but it does allow us to explore AI for a number of these things. So whether we're looking at process optimization or continuous improvement, or whether we're exploring AI for like protein engineering. Those are things that we're very interested in and actually have doing internally, got some collaborations with some other companies to explore this. And so that's pretty exciting stuff. But what we really need to do is we need to base that on good data at the beginning. So that's kind of what we're really excited about. But as I said, it's always got to go kind of back to like meeting the market needs. So as excited as we can be about it, speeding up the research is really to kind of make this a better experience for the customers. So I know that I started a little bit later in the session, so I'll end it right there. And happy to take any questions, but you can't really underestimate the blocking and tackling, the importance of that.